We are here today to talk about banishing slow queries with intelligent query processing. Earlier I'd asked about, and I know as people trickled in, there was one gentleman that was running SQL 2022 in production. There's about 40% running 2019 in production right now. I'm John Morehouse, and my clicker is not going to want to work today. Come on, it was working before. There, now it's working. Sorry about that. I'm a principal consultant with Denny Chan Associates. This is my contact information on the slides. I will make the slides and any demo scripts that I have publicly available on a GitHub repo later today, hopefully. But you are welcome to contact me via any of these methods that you wish, whether it's questions about what we talk about today, or even if you got a SQL Server problem and you're stuck on, I'm happy to help out. And if I don't know the answer, I can maybe at least point you in the right direction. That's what the SQL family is all about, is helping each other. So if you've got questions, feel free to drop me a line. I just have to say, this is SQL R Us, not SQL Russ. So Toys R Us, I know Toys R Us is bankrupt in the United States, but SQL R Us, because I touch just about every facet of SQL Server. Just don't ask me to write reports, because I can't make them look pretty at all. I live in Kentucky in the United States. I'm an avid blogger, tweeter. I'm involved with the data platform community as a whole. Essentially, I'm a really big nerd, and have been for years and years and years. Quick shameless plug about Denny Chan Associates. We're a bunch of fellow nerds. We like to solve business problems with data solutions. And SQL Server, you need a project, drop us a line. That's simple. What we're going to talk about today, we're going to talk about what is intelligent query processing, where did it come from, what caused that feature to come to life. And we're going to talk about lightweight query profiling. We'll talk about table, variable, deferred compilation, memory grant feedback, parameter sensitive plans, and then degree of parallelism feedback. And I do have demos. You will notice that this is a small subset of what the intelligent query processing platform actually has to offer. They've expanded things as time has gone on, and that's no different with 2022. So I had to pick things that I thought were relevant to a data professional that would be really, really cool. So a quick show of hands, how many of you are database administrators, DBAs? All right, so about 70%. How about developers? Oh, okay, wow, okay. You guys, wow, sweet, awesome. And there was about, for those at home, about 70%. 60-40 it looked like, maybe closer to 50-50 of DBAs and developers. So as a DBA, which is what I am, I'm a diehard DBA, these four features are super important to me because they make my job significantly easier as a DBA to fix performance problems when they arise. So originally it came out as adaptive query processing in SQL Server 2017. And so when it originally came out, it was AQP. And then later in life, they rebranded it into intelligent query processing. And this really came from a challenge that we probably have all faced. How many of us have had management or customers, hey, we need to make this faster, but you can't change a lick of code. It's a pain in the tuchus. It's sometimes very, very difficult to make things go faster when we can't change the actual underlying code. No offense, developers. You use your entity frameworks, your ORM methods. Sometimes it gets really, really hard to make things faster when we can't change that code. We can't change SQL code, we can't change the .NET code, we can't change the application code. It just makes it really, really difficult. With that challenge, Microsoft said, we can fix this. And so what they did is they introduced lightweight query profiling. So this is a feature in the database that now will start to track and monitor and retain some of the metrics from your queries to help introduce a framework where we can actually make some informed decision. The engine is going to make this decision on how we can make things better, whether that's DOP feedback or memory grant feedback or whatever. In order to facilitate that, we have to have some mechanism behind the scenes to start collecting that information. And so that's what that framework is. So lightweight query profiling is the first step of that. If you are not on 2019 or higher, you have to opt in. There's a trace flag, I think it's 7412. 7412. So if you are lower than SQL 2019, you have to enable trace flag 7412 to get that lightweight query profiling. If you are 2019 or higher, you have it enabled by default, all right? So if you're lower than 2019, you gotta turn on that trace flag to get that feature started. Most of the cases use Query Store. Who uses Query Store? If you're not using Query Store, you're doing it wrong. Query Store is the best thing next to sliced bread when it comes to query performance tuning in SQL Server. So if you're 2016 or higher, enable Query Store. It's amazing what it will tell you. It's amazing what it will help you solve from a performance level problem. As we go on, you will start to notice that new features, especially in like 2022, require Query Store. I have no knowledge of this, but my professional opinion, Microsoft is going to rely more heavily on Query Store. So the sooner you start to use Query Store in this progress, or your journey into intelligent query processing, the better you will be. And you'll be, long term, you'll be better anyways for performance problems. So start looking at Query Store if you're not already. This is the roadmap of what intelligent query processing. This comes from Microsoft. You can actually find this on learn.microsoft.com. Originally in 2017, we just had a couple of features that we were able to utilize, and they are in the light blue. And then in 2019, we added some, and they are in the white. I really wish that they had done this backwards and done white, light blue, dark blue, from a color perspective. And then in 2022, we saw some new features come out, released. We actually saw some of it. Who went to the keynote yesterday? They did a bunch of the demos in the keynote, and actually some of the demos I get to repeat here. I didn't know they were doing that in the keynote, but we saw some new features, some really awesome features in 22 that came out. The ones that I picked was the degree of parallelism feedback and the parameter sensitive plan optimization. So those are the two that we're going to look. The other thing with intelligent query processing is compatibility level. Who is using compatibility levels to gauge where their databases are in their production environment in terms of what query optimizer and query cardinality estimator they're using? Anybody got lower levels of cardinality or compatibility levels than their version? Yeah. And what that means is I can run SQL Server 2022, but set it to compatibility level 2019 or lower or whatever. Microsoft, if you haven't seen, Microsoft is starting to certify databases and applications based off what compatibility level you're running. So in conjunction with Query Store, some of these features are compatibility level driven. You have to be in 2022 compatibility level to get some of the new features, or 2019 features, or 2017 features. But Microsoft is no longer certifying applications or software vendors based off what, way back in the day, they used to certify it based off, you had to run SQL Server 2016 Enterprise, this build, this CU, cumulative update. Now they're saying, what compatibility level you are in, we will certify that it will run like it was on 2016, or whatever compatibility level you're set. So if you're not familiar with your compatibility levels, start looking at what your databases are, because you're going to have to adjust them to get some of these features. Bless you. With the intelligent query processing features, as well as when AQP released, we started to get some new DMVs that would allow us to see some new information that it was collected. So that first one, the exact query statistics, we are actually able to see some query information as it gets in flight. Who has ever tried to glean the query cache to find what the query plan was of a query that you executed 5 seconds ago, and maybe your system's so fast it got ejected from the cache? Anybody ever do that? Yeah, and you're hoping, you're crossing your fingers at your desk that it's still in the cache and you can find it. If we look at this DMF, which is a dynamic management function, we can actually see query statistics of that query as it happens in flight. So we're getting new information out of some back-end metrics, so we can actually see that metrics in flight as it goes. We also have another one, DM exec query plan stats. This is more in line with the lightweight query profiling. So once the query finishes, we now have what that actual runtime metrics was of that query plan. If you go look at a query plan in cache and actually extract it, it might not have the actual runtime metrics, This will. We can actually get the actual physical runtime metrics of your query from this dynamic management function. And then we have another option that came out, last query plan stats. This is a database scoped configuration that you have to enable on the database in order to gather that last plan stat. If you look, when did database configurations start? 2016, 2017? Do you remember? There's a system management view called sys.database scoped configurations. You will actually see all, and we can look at it in the demo, you can actually see all the new features that Microsoft are making at a database scope instead of a server level scope. Right? You can now set your max DOP on a database. You can now set all the IQP features enabled or disabled on a database level, not in necessarily a server level. All right, and I'll show you all the DMVs and stuff. Let's talk about table variable deferred compilation. Who here uses table variables in your code? Yeah. So how many of you have noticed performance issues with table variables as time has gone on and your volume of data has grown? Who here actually deletes data? Oh, look, one. There's one gentleman in the back that deletes data. Table variables has always been a bane of problems for most data professionals, in part because of the way that SQL Server handles it. If you don't have intelligent query processing enabled, SQL Server says, I have a table variable. I don't care whether or not you have 1 row or 10 million rows in that table variable, you get 1 row. Right? And what do you think that does to your plan stats when you try to execute that plan? And it's got 10 million rows and not just 1. Your cardinality estimation is completely out of whack, right? And so this is a problem that's been in existence for us for a long time, and that's the difference between table variables and like temp tables. We like temp tables because temp tables have statistics. We can do indexes. We have a better cardinality estimation of rows in a temp table, excuse me. So in 2019 or lower, we always had a 1 row fixed estimate. There was no way to get around that, right? So unless you were in 2019, you always had 1 row. Didn't matter the number of rows that you had anyways. Too many rows, we got a bad execution plan, right? If you really honestly had 1 row in your temp table, hey, it worked great. It was hunky-dory. But if you had that 10 million, performance sucked. And so that's why we like the temporary tables, is because we can do things to get a better estimation of how much data we have in that table variable. Now, with 2019 or higher, we actually shift the compilation of the table variable to the first actual execution of the statement. So what that allows SQL Server to do is say, hey, I've got a table variable. I'm not going to estimate 1 row anymore. I'm actually going to wait and defer and figure out how many rows that I actually have in that table variable. And so we get a better cardinality estimation instead of just a wild-ass guess. And so SQL Server performs better. Our code performs better. But the other catch is, if I just enabled that one feature with a click of a button, did I make any code change? Nope, I made zero code change. So you developers don't have to recompile. We don't have to change store procedures. We don't have to change anything. I can make this more like a temporary table with a simple enabling of table variable deferred compilation. So again, you gotta be on 2019 or higher. But this is all the features that I'm talking about today are features that I would use to go back to my management to say, I can pick a number, of the performance issues we have today if we upgrade. Because these will help us get better performance. If we get better performance, we sell more widgets. We sell more widgets, my customers are happy. If I make more money, I get a bigger bonus. It's all about me, because I want money, because that's just how I roll. So table variable deferred compilation is really slick. Memory grant feedback. This is another one that I absolutely love as a DBA. Who has ever experienced or looked at an execution plan and you saw table spills? Anybody know what a table spill is? What's a table spill?
I think it has enough RAM.
Yeah, so a table spill is basically when the query gets more memory than is actually allocated. than possible, and so it spills over to TempDB. So if you look at execution plans and you see table spill, it's touching TempDB, which is a performance inhibitor. Memory Grant Feedback came along and said, hey, we can fix that too. In 2017, they released it for batch mode, which was really about column store indexes. Column store indexes uses a batch mode operation where it actually processes 900 rows in a batch, basically. And we see this later in 2019 for row mode, which was great. So if you're in 2017, you can use it for batch mode, which would be super analytical workloads, not OLTP per se. With 2019, they added row mode, which made me as a transactional DBA where I have transactional workloads super, super excited because I could take advantage of this and do better with my memory grants. In this one, this is where they start to require query store. There is a memory grant persistence, which means that that memory grant is persisted into query store. So it will survive reboots, failovers, anything else. If you don't care about that, you don't necessarily need query store for this feature, but this is another one of those things that says, hey, they're relying on query store more and more. If you're not using query store, you need to be looking at it because it's super important. So what does it do? If we know that if a query has not enough memory and needs more, it'll spill over to TempDB. It'll actually increase memory grants if the query spills to TempDB because the query is starving. So SQL Server starts to track some of these metrics, right? On subsequent executions of that query, because what happens is the query will run the first time, there'll be a memory grant issue, SQL Server will identify it. When you run that query again, SQL Server is smart enough now to say, oh, hey, when you ran this the first time, you had a memory problem. I'm going to give you more memory on this go around so we can allocate that memory better. Right? If you have too much memory, if I run a query and I get a memory grant that is deemed excessive, SQL Server now can adjust that the other direction. Because if I have a query that consumes all the memory, what did I just do to my neighbors who are also running queries? I just starved them of all their memory, right? So memory grant feedback, now we can dynamically adjust your actual requirements based off your needs. And so you get a much better balanced profile of memory utilization when we enable memory grant feedback. This is also another one that as a DBA, I absolutely love because again, I can solve performance problems with a simple, I'm gonna turn this feature on and let it go. And I changed 0 code, right? Parameter sensitive plan. Who has ever dealt with plan sniffing? So plan sniffing is, and for those at home, that was probably about 30% of the room. Plan sniffing is not necessarily a bad thing. Sometimes you'll get knee-jerk reactions that, oh, I got parameter sniffing. That's horrible. It can be, but that's the way SQL Server is supposed to work. Plan sniffing is that when you have multiple plans that accept a parameter, a value of 2, 3, 4, whatever, SQL Server will generate an execution plan based off one value, and the other value may not have the correct data, statistical data to utilize that execution plan effectively. A good example is, and we'll see it in the demo. The demo I have is I have a table that's got 20 million rows. And those 20 million rows are all attached to a single customer. I have another customer that has 2 rows. So if I pass in a parameter for that query or that customer that has 20 million rows, SQL Server is going to make a decision on how to go fetch those 20 million rows. Now those 20 million rows are coming from my laptop. It's not like I've got a beefy server sitting out there somewhere. On subsequent execution, if I'm looking for the customer that has 2 rows, because I've already executed the plan that's got the 20 million rows, that's a really bad plan to find 2 rows. Because that 20 million rows, I'm going to want to do a complete index scan. And for 2 rows, I should just be able to use an index seek. So parameter sniffing is a great feature. It is SQL Server 2022, so you have to be latest and greatest to take advantage of this. It does help us solve the parameter sniffing issues. It doesn't solve all of them. unfortunately. It helps to get us there. I suspect that in future releases, and again, I have zero knowledge of this, I have no insider knowledge, I suspect that they're going to work on this and continue to fine-tune this to do a better job of being a little bit more widespread of solving the parameter sniffing issue. It does only currently work on equality predicates. So if you've got parameters that are doing greater than or less than, it's not going to work. But if you're doing straight up equality predicates, where ID equals 2, ID equals 4, the PSP can actually engage and help you solve the parameter sniffing issue. And we actually see some new objects and constructs that came out with this feature that came out. We actually have the original query, and SQL Server actually starts to keep track of two different things. One is called a dispatcher plan that we can actually interrogate in Query Store, and a query variant. And so what happens is basically the Query Store and the engine, the initial compilation of the query that has the parameter, SQL Server says, hey, you're the first one. I'm going to compile your plan and generate your execution plan. But I notice that you've got a parameter, so I'm going to go ahead and generate a dispatcher plan and query variants based off the data statistics that you have in your tables, your table that you're looking for in terms of the volume of data. So we will actually start to get multiple plans for the original. And really there's a diagram that I've got, I'll show you. The cardinality evaluation is at runtime for the parameter values. So it doesn't matter, you don't have to pass in multiple parameters. SQL Server is actually going to use the statistics of the table to figure out the top 3. And then those top 3 become your dispatcher and your variant plans. And that's the buckets. So the top 3 are placed in 3 predicate cardinality buckets via the dispatcher. Let me just show you this. This probably explains it a lot better. And this image came from learn.microsoft.com, I believe. So if I have these 3 agents, 1, 2, 3 on the left, the number of listings, 20, 76,000, and then 1.1 million. I get the first parameter query is what we would call the parent query. That's the parent plan. We have a dispatcher plan, and then we've got 3 individual variants on each side, depending on which the number of listings that each agent has. So this is agents with less than 10,000 listings, agents between 10,000 and 1 million, and then that one on the third, on the end, is higher than 1 million. So depending on which parameter you pass in on subsequent executions, you will fall into whichever plan the variant puts you, or the dispatcher puts you in. So essentially, as a parameter, or excuse me, as a query comes in, the dispatcher plan is going to look at your parameter and say, oh, you have ID 1, you're going to fall over here where your execution plan is better suited for that smaller amount of data. Make sense? Right? That's how we kind of get around that parameter sniffing problem. It's only 3 variants. So again, it doesn't solve all of it, doesn't solve all of your parameters. It helps to put it in the right bucket so you potentially have a better chance of getting the appropriate plan for your data. Yes, sir.
For the numbers when the dispatcher will put it into different buckets, so let's say less than 10,000 is the minimum what we have to have for the first bucket, and
No, so let me make sure I got the question right. So the question was, are these 10K, the 10,000, 1 to 10,000, 10,000 to 1 million, then 1 million or higher, are those fixed? Is that correct? Did I get your question right? Yeah. No. So those values are going to be based off whatever your data is within your tables. So SQL Server is going to utilize the statistics. We all keep statistics updated. Yes? Yeah? Everybody should be nodding their heads. Yes? To determine what those buckets are. So SQL Server will determine that. Good question. Down here, I wanted to point these out. Again, if you're not using Query Store is awesome. We have new things that came out with the parameter sensitive plan feature In the query store, we can actually start to look at what those variants are. We can actually look and write queries against these DMVs to find not only our parent plan, but we can also look at the dispatcher. We can also look at all the variants and see what the differences are of those query plans, maybe what those values are in terms of the buckets. But we can utilize this to start to do some deeper level metrics as to what our parameter sniffing queries are doing. So these are super important when you start to look at this feature. Again, it's 2022. But this is another one of those features that I would take to my management and say, we need to upgrade, and here's why. Yes? I believe so, yes. Yes, I think Query Store has to be enabled. I know Query Store has to be enabled for the DOP feedback. I'm almost positive that it has to be enabled for the PSP to function. Good question. Repeat the question. On-screen question. I have an on-screen. Is it PSP which is restricted to 3 attempts before it decides it can't help? So the question is it PSP which is restricted to 3 attempts before it decides it can't help? I'm not sure about that. I'll have to come back and find that one out. I know that DOP feedback will regress. I will come back to Nick. Degree of parallelism feedback. This is another one of those DBA features that is one of those things that is fantastic. How many of us have fought the DOP monster and tried to find that magical combination of cost threshold for parallelism and your Maxo DOP setting on your server to get the best performance? We've all done it, right? How many of us have actually won that battle? Yeah. There's only like 3 people that raised their hand on winning that battle. This is that magical thing. So DOP feedback, it uses the elapsed time and waits to identify an inefficient parallelism for repeating queries. So if we have queries that come in repeatedly and the DOP, the degree of parallelism is not good for those queries, SQL Server in 2022 can now start to track that. And if that happens, we actually can get some metrics out of that. Query Store is required for this. You have to be on 2022, obviously, but you have to have Query Store on. If a plan regresses, there's the documentation on learn.microsoft.com says that this feature will never increase the DOP for a query. Now, what it will do, however, is it'll actually regress to the last known, right? So in that case, you might see it go up, but that's probably really a regression that it has tried to gate the DOP down, but in reality, it's now gone backwards and has regressed. So it won't go up. It also won't go beyond the DOP setting of the server. On-screen question. Will these slides be made available after the session or later on? Yes, the slides and the demos will be made later on. I have a GitHub repo. I will publish them to my GitHub repo, and I'll figure out how to tell bits where they are. If you do plan forcing, so if you go into Query Store, if you haven't gone to the Query Store, you can force execution plans in Query Store with a single click of a button. That's also a fantastic feature of Query Store. If you force a plan in Query Store, that forcing will also honor the degree of parallelism feedback. So this is kind of how it works. And if you want this slide, this image came from this slide deck down here from learn.microsoft.com. So basically we have a SQL query that comes in into the engine. The engine utilizes the query stats. Is the query eligible for DOP feedback? If so, we provide feedback. We validate that feedback. And then is that feedback stable? And so SQL Server actually does some stability checks and says, hey, did my change actually work? If not, I need to regress because I'm doing harm. And that's one of the things that if you listen to the folks, the program group at Microsoft, one of their tenets is do no harm. So as they make enhancements to the IQP family of features, they don't want to do any harm. They don't want to cause your server to crash, right? And so they will check to make sure that their changes actually are valid. If not, they'll revert back. If it's stable, we send it to Query Store. The Query Store will change the DOP feedback and back to the query processor, and round we go until we find a stable DOP. The demo I have takes 30 minutes to run. I ran it early, so you all don't have to sit there for 30 minutes. It will see in the, and there's extended events that will show this, but what we'll see is as this cycle happens, you can actually track that in extended events. And we'll see that we start out like 16 DOP, it goes down to 12, 8, I think it goes all the way down to 2, and it decides that 2 is not stable, and then it goes back up to 4. So we'll actually see that in the screenshots where we actually see that progression down and then come back up. Won't rotate up unless it's reverting. DOP2 is the minimum value, which kind of makes sense. It won't go any lower than 2, because if you go down to a DOP of 1, that's kind of pointless. Query hints. Anybody use query hints? Oh, a good number of you. There's probably like 10% of you. Well, I tend to stay away from query hints myself. But if you use query hints and you specify a DOP hint, which you can do in the query itself, this feature will actually honor that, and then whatever you set in the query hint will be the new ceiling. So that's where it'll start and then try to work its way down, right? So if you've got those query hints in there, this feature will work seamlessly with it. Just know that if you start to look at the execution plans and go, oh, wait, that's not the server level setting of the max DOP, I'm seeing different numbers, go look and see if you've got a query hint somewhere, because that's going to adjust where your ceiling limit is. On-screen question. Get the plans updated when the statistics change. I'm not sure what he's referring to. I need clarification on that, Christian.
If you do a load to the tables where you have plans for, and you critically increase the data in it, you update the statistics get updated, and the formerly made plans may not fit for the consideration.
So in that case, let me just repeat that to make sure I got that. If you make data volume changes, you make data changes, you update statistics, will that affect this? Yes, it should. So because if you rebuild statistics, you've invalidated the query plans in cache in the query store. So that should change. But it should go back to the exact same process, right? So once you you update statistics, the same thing is going to happen though, because your query is going to come in and say, hey, we've got query stats, we've updated query stats, go back through this cycle, and then determine whether or not DOP can be adjusted up or down. That's what I would expect to see. Good question. Oh, whoops, I missed one. DOP feedback is replica aware. Who's using availability groups? Yeah. So one of the things that I love about Microsoft is that they're putting features in that are replica aware. So if you have a query that is doing DOP feedback on your primary replica and you fail over, that query is still there, that it'll honor that feedback once you fail over to that other replica, right? Great feature. All right, any questions about any of these features before I jump into a demo? Because I've got like 20 minutes. Yes, sir.
Regarding the replica aware, will it also be modified on the replica? Because we're running offload queries on the replica itself, so will the DOP feedback work on that as well, or only on the primary?
Should work on the secondary, assuming that your secondary is readable. Yeah. Yeah, because this is a query, you have to have query store. Anything that happens in query store is now being pushed to the secondary. So I would, as long as your secondaries are readable, you should be able to see that same behavior in the readable secondary. Good question. All right. Any other questions before I jump into demos? Yes, ma'am.
Going back to the memory grant.
Yes.
Say it balances, so you allocate more memory and don't starve that later in query. As a DBA, do you have any way to kind of give priority to, queries that hit certain tables to say, well, actually, if you're querying that is a priority over another query without taking memory?
So the question is there any way to, as a DBA, to give priority from a memory grant feedback perspective, whether or not it's got priority over a different query. I don't know of any way. Do you know, Monica?
No, you can't, but there are a couple of hints where you can set min and max memory percents that you can put in there, so you can tell it to give me this percentage for this, or this amount for this query. So you may get a better grant there, but you can't set a priority and say, this run,
Yeah.
release memory, so this one can run as a priority.
So it would be a hint of some sort. And the answer back at home was you could do a hint, but there's no way to actually do it from a priority. Like this query has priority. Okay. Can you all see that? Is that okay in the back? Good? Okay. So the first demos we're going to have is, and if you're curious, I'm actually running a Docker container on my Mac. I know I'm evil. I work in Microsoft stuff, but I run a Mac. I run Apple. All the demos will use Wide World importers. So it's a free sample database that you can go out and download online. The last two, the parameter sniffing plan and the DOP feedback, you have to explode the data. So I actually had to explode the data to like 20 million rows to get the demos to work, which takes some time. But if we look first at the table variable deferred compilation, so I've got wide world importers. Whoops. Come on. I have a store procedure here that I'm going to create. It's actually already there. And basically, we're going to declare that table variable with a bunch of columns, and then we're going to do some work on that table variable within the store procedure. Just to make sure that it's there. Now, the first thing I'm going to do is I'm actually going to set the compatibility level down to 130. 130 is equivalent to 2016, right? So I mentioned earlier that compatibility level is super critical with these features. So right now, Wide World Importers on the SQL instance on my laptop is running in a 2016 mode. If I run this, so I execute the store procedure, whoops, and I need to turn on the execution plan. If I scroll down, where's my scroll bar? Oh. Where's my query plan? Come on. Azure Data Studio has a funky glitch right now. If we look down here, we can see that my table, and remember, I'm in 2016 mode, right? So I don't have the table variable deferred compilation option enabled. We can see that my estimated number of rows per execution is 1, when in reality it's like 228,000, right? So SQL Server just says, hey, I got 1 row, my stats are off though, and so my performance sucks. Or could. If we extrapolate that out, we can see that we have 1 row, but if I update this back to 2022, which is 160, so 150 is 2019, 160 is SQL Server 2022. If I run this again, my mouse is all jacked. Scroll this up. And I look at my table variable, we can see on the far left there, my estimated number of rows per execution is now 228,000. So what SQL Server's now done is said, hey, I'm running in 2022 mode, compatibility. But because I've got this table variable, SQL Server says, hey, let's defer the compilation of that table variable until a point where I can get a better estimate of how many rows that I have to read, right? So I can almost guarantee you that, depending on your code, I can't always say 100% positive, because that'll bite me in the butt. If you are on 2019 or 2022 and you enable table variable deferred compilation, you're going to get a better performance out of your table variables, right? So we get a better value and a better statistical for cardinality estimation, knowing that we have 228,000 rows in the table variable versus 1. Really simple demo, but I think that's really cool to see the difference between the 1 row in the table variable and the 228,000 that is actually there. Memory grant feedback. This is another one that I thought was really cool. I'm going to set this down to 140, compatibility level 140, which is 2017. So SQL Server thinks that it's going to run in the 2017 mode. I'm going to just change that. This is just verifying that my memory grant feedback. We can see here that in the database scoped configurations DMV, these are the 2 memory grant feedback options that we have, batch mode and row mode. And they are enabled, and so we can see that they are enabled for both batch mode and row mode. I want to execute this query. I got to turn on the execution plan. My mouse is like super sensitive that I need to fix later. This is where I just use my keyboard. So this is normally what happens. We get a bang symbol. That's what the exclamation point is. We get a bang symbol. It says, hey, the query plan's telling us something's wrong. It's throwing a warning over here on the top of the select operator here in the query plan. So if we go hover over that and look at the properties, we're going to get this nice little we will see this if you're not using Azure Data Studio and you're still using Management Studio, you can still find this information in Management Studio. But we can see there the grant warning kind is that we've got an excessive grant. So what's happened is SQL Server has granted this query more memory than what it actually needs. So if this was a production system, I'm actually effectively starving other queries that could use that memory. Because SQL Server is going to allocate that memory to that query. Once it allocates that memory to that query, nothing else can touch that memory. Right? So we've effectively starved other queries. So now if I enable 150, which is 2019, and I could even do 2022. See if my mouse will let me. Nope. So I run the same query, right? I've updated the compatibility level to 2019 where I can actually utilize the memory grant feedback feature. So the query is going to run. We notice that we still have a warning sign on the select. And we still see we have that excessive grant. I don't know, can you all see that in the bottom? So we requested that memory, we granted that, we got that granted memory, but we still have an excessive grant. Why do we have that warning still there? Because it's the first time we executed the query after we enabled the feature. So once we enable that feature, SQL Server then has to say, okay, we're ready to start tracking this. Run your query, right? So if I come back and say, let's run this again. And I'll get to your question in a second. Oh, okay. We now see that the memory grant is gone. So SQL Server now has said, hey, because you had an excessive memory grant in the past, we're going to adjust things now. And we can actually go a step further and actually look at the execution plan. Let's see if this works. I gotta find it. Right here. So one of the things that you'll see, if you've ever looked at the XML for an execution plan, this is what it looks like. if we look right here, in 2019 or lower, I'm sorry, 2017 or lower, you won't see that actual XML node. But now, because SQL Server is keeping track as to the memory grants for each execution, we actually can look in the execution plan and say, yes, SQL Server is adjusting the memory grant feedback, and we can track that in the XML. Really cool stuff. Well, how much code change did I do? 0. I changed the compatibility level of a database. If you're in Azure, most of the stuff is enabled by default anyways. Right? So if you move to Azure SQL Database, create a new database, these things are enabled by default. 0 code changes. That makes me happy because I'm a lazy DBA. I don't want to make changes. Yes, sir.
In Azure, do you still need to adjust the compatibility?
Depends. So the question is, if you move to Azure, do you have to adjust the compatibility? Yes. If it's a new database in Azure, no. Because a new database would have the default, whatever, start off at 2022. Then you can change it. But if most people, and that's a big gotcha that people make migrating to Azure. If you're going to migrate to Azure, always go double check your compatibility level, because I have clients that have moved to the cloud and they're still in 2008 compatibility level. 2008 R2, I think, is the lowest it'll go. So that's a huge thing. I've only got a few minutes left. So we'll look at sensitive plan real quick. This is the one that relied on a large amount of data. Same thing, I've got a procedure here that is going to get a parameter, whether it's 1, 2, 3, or 4. And if we execute that, and I've set the execution or the compatibility level to 160, because we need that. If I run this with a value of 2, and let's enable the plan real quick, we can see that we get an index seek. For a parameter of 2, the index seek is the best plan, but now if I were to come back and run a different plan, that's not what I wanted. Here's my scan. If I execute the procedure with a parameter of a value of 4, because value of 4 has the 20 million rows associated to it. And this is going to take a little bit of time, but to the short answer, a spoiler alert, I get an index scan, which makes sense because this customer with the ID of 4 has 20 million rows. SQL Server is going to say, that's a lot of rows. I need to scan the whole table. An index seek is not going to give me the performance that I need, so I need to scan the entire table. And so at the end of this is that now I've got 2 plans. I've got one plan for a smaller data set that gives me a seek, and another plan for that larger data set that gives me the scan. Oops, cancel. Did that finish? I don't think that finished. We can look at some of these. That's not what I wanted. So these are the actual parent queries, and so we can start to interrogate the query store to actually see those parent queries. We can also interrogate the query store to look at the plan variants that I mentioned earlier, right? We have a dispatcher plan, then we have plan variants, and we can bring them all together. So if we wanted to see some of that, we actually see new plan types. There's my dispatcher plan. There's my 2 query variant plans, right? So I have an initial dispatcher plan, then I've got the 2 variants for the 2 different parameters that I've passed in. And so now SQL Server can make better guesses. I've got 1 minute left. Oh my gosh. DOP feedback. One of the things with DOP feedback, just like with the parameter sniffing plans, in order to actually fully run the demo, it takes 30 minutes. It did on my laptop. So I shortcutted this for you. I'm going to run a few minutes over is my guess. But really what I wanted to show you here is this. So in this, we can see that at the very top, SQL Server has identified, and this is running SQL 2022 on a VM in Arcolo in California. So I'm actually looking at a server in California. We started off that the query was identified as feedback eligible. We started out with a query DOP, max DOP of 16. This is a 16 core VM, and so the max DOP on the instance is set to 0. So we started at 16. And then we can start to see that SQL Server started to give feedback. We gave feedback. We think 12 is going to be a better value of DOP, right? And then it goes all the way down, and we can actually see that it all went down to 4. But we can see how it kind of stair-stepped down, right? So DOP feedback is a great option. We can also look in Query Store. Again, not in Query Store, super great information. We can see how, and we're looking at the CPU time for that query. We can see over time as SQL Server continued to execute that query, the CPU time actually started to decrease. Not only CPU time, but the duration. Oh, I didn't have that up. Oh wait, duration. If we look at the duration of that query, we can see the pattern was the same. So as DOP feedback got enabled and acted upon, we can actually see our performance gets better over time. Query Store gives you all this information. That's great stuff. Any questions on the demos real quick? Cool. As a diehard DBA, these features make my job easier. Makes any data professional easier. Real quick, we'll wrap up and we'll be done. Of course, Microsoft says, unfortunately, some of these features are enterprise only because Microsoft wants your money. Unfortunately, helps keep me employed. Table variable deferred compilation is both enterprise and standard. Parameter sniffing plan, thank you, good Lord. This is also standard. So if you run SQL Server standard in your environment, you can use PSP to take advantage of that. Unfortunately, memory grant feedback and the DOP feedback, you have to be on enterprise. If you're in Azure, you're on enterprise, you get that right out of the gate. Summary, performance game changer. Because I'm a DBA, I'm concerned about performance tuning, but I want to do performance tuning that's the most easiest and the most least invasive method possible. You saw me just change some compatibility levels and I got new features that made things faster and made things better. Increased flexibility. Again, I'm lazy. I want to be able to just click the button and make things go faster. It's not the turbo button, but it does make things go faster. Compatibility levels, query stores, make sure you go back and look at your environment for those. It really helps us to get rid of bad anti-patterns, right? So if you've got legacy code and there's a ton of table variables, we can say goodbye to that bad anti-pattern without having to rewrite the entire code base. Anybody support legacy code that is millions of lines long? Trying to fix that stuff is a nightmare, right? So again, these features help us to get rid of those anti-patterns pretty easily. With that, I think I'm over by 2 minutes. 2 minutes. How's those 2 minutes? Feedback. Tell me, feel free to give me feedback. I'm a big boy. If you hated it, feel free. But tell me what I can do better, what I did wrong. Contact me if you got any questions, and I'll be here for the rest of the conference. So thanks for